Hi, this is the continuation of my previous experiment, the electromagnetic induction, where I use an induction stop and aluminium foil. Today I am going to do one more experiment which is related to the concept of that experiment. In this experiment I am going to use a copper pipe. This is a copper pipe. This is a copper pipe and a small piece of iron, which is a magnetic material, and a very strong magnet. This is a rear arc a magnet. It is very strong, it's very powerful. So let me keep like this, and I am going to use one more small magnet which size is similar to the iron which I have here, which is similar to this one. So I am having one iron and another one is a magnet. So this is a rear arc and it's called neodymium magnet. And I have one more copper plate. This is a copper plate. It's a very thick and heavy copper plate. Its weight is around 5 kg. But if you want to see, let me take it out. So this is the thickness. This is the thickness of the copper plate. So this is the thickness of the copper plate. Okay, so for my safety I put it inside this block so that I can handle it easily. So these are the materials required for doing this experiment. The name of this experiment is Newton nightmare. Newton nightmare. If you want to search in YouTube or if you want to read more about this experiment, you can search as a Newton nightmare experiment. Why it is called Newton nightmare? Because according to Newton's, when we drop an object, the object falls at 9.8 meter per second square. That is what, according to Newton's laws of gravitation. So if I drop an object, so it falls down at an acceleration of 9.8 meter per second square. That is called the acceleration due to gravity. So if I drop this one, it falls at 9.8 meter per second square. Why it is called the Newton's nightmare? Because in this copper pipe, if I drop this, let's see, if I drop this, it exactly falls at 9.8 meter per second square. So no slow down, nothing. So this is what very quickly, as soon as when I drop it, it's same as without this pipe, same as like this. Now, if I am dropping a magnet inside this aluminium pipe, then what will happen? Let us see. So if I drop this one, so this is a instead of this iron, I am using the magnet now. So let me drop this one. So when I drop, it takes considerable amount of time to come out from the end of the pipe. So it means that when this object, in my case it's a magnet, when this magnet is falling inside the copper pipe, it experiences an opposing force. Now the question is from where that opposing force is coming, because if you see it doesn't stick. The copper is not a magnetic material, so there is no attraction, there is no force of attraction between this magnet and the copper. But when I drop this magnet inside this copper pipe, it slows down. See? Let me do once again. See? Oh, it's stuck because okay, let me change it. So it slows down. So let me do here. So what is going on inside this pipe, we cannot see it properly. So because of that, I have made 2 holes in the pipe so that you can see the falling down of the magnet at this particular point. So let me do the experiment once again. So I hope you will, let me turn this hole towards the camera. So if I drop this one, so can you see that? So it takes considerable amount of time to come out from this end of the copper pipe. It means that an opposing force is acting on this magnet, even though there is no attraction between this copper and this magnet. There is no attraction between these two, but when I drop it, there is a force acting on this magnet. Now the question is from where the force is coming, how it happens. That is very interesting. Now, since we are not able to use the not able to see the falling magnet, I have this big copper plate and this big magnet, and let us do some more experiment so that we can see it properly. So this is a bigger magnet. Now I don't want to keep this small iron pieces nearby. Let me keep it a little far away because this is very strong. So if I try to drop this magnet, so let me drop this one first. So can you hear the sound? Now if I drop this one, let us see. If I drop this one, can you hear the sound? Can you hear the sound? No, it means that this magnet is experiencing a what? An opposing force. This also slows down. The magnet inside this slows down, but we cannot see. But here we can at least, we cannot exactly get the clear numerical figure like how much opposing force is acting on it, but that is very clear that it slows down. Otherwise we can hear the bang sound of this magnet on this copper plate, but we are not hearing it. Okay, we are not hearing it. Other way, if that is okay, that this is not visible, but let us do other. So let me try to do it this way. Let me push it this way, slowly. Yeah, can you? So here also I don't hear any sound, any banging or anything. So and then okay, let us try to roll it then. So it is not rolling. Means something is stopping the magnet to move forward or to roll forward. Okay, it's very interesting. It's very interesting. Now, one more tool. Let us do one more variation. This is a magnet, and I will, if I do like this, and if I do it quickly, okay. So it is not falling quickly. Can you see? Let me do once again. Can you see? It slows down. It means that a force is acting on this magnet and which is opposing the magnet to move the way how we want to make it move. Let me try to give some clue. When we move there are magnetic field around this permanent magnet. When we move the magnet, obviously the magnetic field around this magnet, in this, if I consider this particular area in this space and if I move like this, at this point the magnetic field is changing. In a changing magnetic field, if we keep a conductor, or if we keep a coil in the electromagnetic induction, in a varying magnetic field, if you have a coil, an EMF will be induced, and if the coil has a complete circuit, then a current will start flowing through it. So I'm just giving some clue, but I have shown you the way how you see while doing this experiment. My point here is, let me know your answer, and obviously I will try to explain this one in coming videos, but I just want to interact with the students or with whoever are interested in doing this simple experiment. I want to do a simple experiment. So if you share me your views, if you share me your other way of doing the experiment, I will be very happy. I will try to arrange those things and I will do the experiment. And in coming videos I will explain more. And for today, the Newton's nightmare experiment is giving some more extra information, and not only that, I have mentioned about how a varying magnetic field and a coil interact a little bit. I'm just giving a little clue. So please, if you have the answer, please share in my comment. And as a last demonstration, let me repeat this one once again. Can you see? Yeah. So there are many applications which we can use, because if this is going to help, there are other applications that let us do those coming experiment in the coming videos. But for today, thanks for watching.